Good day everyone. I'm Mariz Dolosa, assigned to present coal-fired power plant in the subject Power Plant Engineering Laboratory under Engineer Jamer Punzalan. So in the first slide, coal-fired power plant are a type of power plant that make use of the combustion of coal in order to generate electricity. We all know what is a coal. In this type of power plant, ginagamit ang coal para makapag-produce ng electricity. So, in second slide, about coal power plant. Their use provides around 40% of the world's electricity, and they are primarily used in developing countries. Countries such as South Africa use coal for 94% of their electricity, and China and India use coal for 70 to 75% of their electricity needs. However, the amount of coal China uses dwarfs most other countries. So noon, di lahat ng tao nakaka-afford na magkaroon ng electricity sa kanilang mga tahanan. Kaya naman, ang ginawa nila, gumamit sila ng coal para makapag-produce sila ng electricity at talagang nakatulong ito sa kanilang pang-araw-araw. Kaya lang, nagpo-produce ito ng iba't ibang uri ng pollutant na nakakaapekto sa hangin at nagkokos din at nagko-contribute sa climate change. So yun, makikita nyo sa kasunod na slide yung background niya na coal-fired power plant sa England. So kung napapansin nyo yung dalawang mataas na tinatawag na smokestacks, bali dun lumalabas yung combustion products, and then yung mga maliliit naman na mas maliliit naman dun sa nakita nyong smokestacks, dun naman lumalabas yung wider cooling towers. So next, burning huge amounts of coal. Coal plants require enormous amounts of coal. Shockingly, a 1,000 megawatts electric coal plant uses 9,000 tons of coal per day, equivalent to an entire train load, 90 cars with 100 tons in each. The amount of coal used during a full year would then require 365 trains, and if each is 3 km long, then a single train carrying all of this coal would need to be about 1,100 km long. So, sinasabi lang dito na once na dumaan sa inyo yung train of loads ng coal, ang katumbas nun is 1 day. If ever na 40 kilometers per hour ang bilis. So, to learn more about megawatts electric or MWE is one of the two values assigned to a power plant. The other being megawatts thermal or megawatts or MWT. Megawatts electric refers to the electricity output capability of the plant. The megawatts thermal refers to the input energy required. Power plants are assigned two values as most are heat engines and therefore can turn 100% of their input energy into electricity. This idea is closely related to mechanical power, how much power an engine can put out. For example, a coal-fired power plant rated at 1,000 megawatts E and 3,000 megawatts T will require supply of 3,000 megawatts of heat from burning coal for every 1,000 megawatts of electricity it produces. That's approximately 100 kilogram of coal every second. This means that it puts out 200 megawatts of waste heat, usually into a large body of water or the atmosphere. 1,000 megawatts electric for every 3,000 megawatts thermal leads to an efficiency of 33%, which is fairly standard for older plants. So next, it is good to understand the difference between the two numbers because in the event of a proposed project, you can understand how efficient a plant will be. The closer a power plant's megawatts thermal and megawatts electric ratings are, the more efficient it is. So, as you can see in the figure, the power input in heat engine is measured as a megawatt thermal, and the output power obtained as electricity is measured as megawatt electric. So next, coal-fired power plants follow the Rankine cycle in order to complete this process. Since they require plenty of water to be circulated in this cycle, coal power plants need to be located near a body of water. The process of coal-fired power plants can be seen in the figure. So, as you can see in the figure, this is a coal power plant process. First, dapat ay ma-unload muna sa train ang mga coal. In traditional way, ginagawa nila, gumagamit sila ng crane para ma-pick up yung mga coal sa sasakyan. Samantala naman, sa mga bagong planta, mayroon na silang tinatawag na floor underneath na kung saan doon hinuhulog ang mga coal at dumidiretso na ito sa kanilang underground containment. So, sa process nila na to, mas mapapabilis sila at di na kailangan huminto pa ng mga train para mag-unload ng coal. Less hassle at less trabaho din ito sa kanila. So, in the next process, pagtapos ma-unload ng mga coal, ang sunod nilang ginagawa is dinudurog nila yung mga coal sa pamamagitan ng kanilang mga large grinder. Kung saan, kaya nila ginagawa ito para ma-maximize yung heat at masiguro nila na masusunog yung coal and ma-minimize din ang pollutant. So, in the next process, after madurog yung coal, sunod naman dito ay susunugin na ang coal at magpuproduce ito ng heat, na kung saan yung heat ay mapupunta sa power plant at dumadaan nito sa pamamagitan ng mga pipes na may mga high pressure water and it boils to steam. So the last process, yung steam is magpo-flow through turbine and then iikot yung turbine ng mabilis na kung saan pupunta ito sa generator. And the generator generates electricity. At ito na ang product na pwedeng gamitin ng mga supplier at ng buong society. So my next slide is the video of a process of a coal power plant to produce electricity.
First Energy operates 20 power plants in the Northeast United States that produce nearly 70 million megawatt hours of electricity each year for over 4 million residential, commercial, and industrial customers. Over half of First Energy's electricity is produced by using coal, compared to about 60% nationwide. Let's see how electricity is generated from coal by taking a virtual tour of a coal-fired power plant, similar to those operated by First Energy. This plant has 3 generating units that produce more than 2,000 megawatts of electricity. At full capacity, this one power plant can produce enough electricity to supply the needs of 1.5 million homes and businesses. Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge but also by rail and truck. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, so over 1 million tons of coal is stockpiled next to the plant. A device called a stacker reclaimer scoops coal onto a quarter-mile long conveyor that can transport up to 900 tons of coal into the plant each hour. Once inside the plant, up to a 30-hour supply of coal can be stored in bunkers. Coal moves from the bunkers to feeders to be measured and moved to pulverizers. Each generating unit has 16 coal feeders that supply 8 pulverizers. Coal enters the pulverizer and spins in a large drum, where hundreds of steel balls grind it into a fine powder. Now a fine powder, the coal leaves the pulverizers and heads to the boiler. About 335 tons of coal can be pulverized per hour. Large fans add warm air to the powdery coal and blow it into the boiler. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy and generating intense heat that changes the water inside the tubes to hot, dry steam. The temperature of the steam is now about 1,000 degrees Fahrenheit. This process generates thermal energy, which is transformed to mechanical energy at the turbine, which is the next stop on our tour. High-pressure steam, now 1,000 degrees Fahrenheit at 3,500 pounds per square inch, is piped from the boiler to the first in a series of turbines. Here it expands between layers of turbine blades mounted on the turbine shaft. The steam loops back to the furnace, then onto the second turbine. In this process, the steam turns the series of turbines 3,600 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge of 34,481 amps at 18,000 volts of electricity. From here, the electricity leaves the plant and begins its journey to customers. After the steam has been used to create electricity, it is exhausted from the turbine and sent to a condenser to be changed back into water. Inside the condenser, steam passes over the outside of pipes filled with chilled water from the cooling towers. The steam condenses to water and returns to the boilers to repeat the steam generating process over again. As the steam condenses, the chilled water inside the condenser pipes becomes warm from the heat of the steam, so it is sent to a cooling tower. These particular towers are called natural draft cooling towers, which are designed with no moving parts. Inside, the water splashes over a series of baffles, which breaks up the water into small droplets. These droplets mix with air from the open bottom of the tower, evaporating some of the water and cooling the rest by as much as 27 degrees. The newly chilled water returns to the condenser to repeat the process of cooling more steam. Since 1971, First Energy has spent more than $5 billion on environmental protection. Our plants are equipped with air quality control systems to remove sulfur dioxide and particulates called fly ash. Fly ash is removed by a mechanical process, and sulfur dioxide is removed with a chemical reaction using lime. These processes take place in large ductwork scrubber trains located between a unit's boiler and its chimney. Boiler gases pass through scrubbing vessels and are sprayed with slurry, a mixture of water and lime. The sulfur dioxide particles and other pollutants are absorbed by the slurry and fall to the bottom of the vessels. A fan releases the cleansed gases through the chimney. By the time this happens, more than 99% of particulates have been removed, as well as 92% of sulfur dioxide. A plant similar to this one can remove over 400,000 tons of sulfur dioxide each year. The scrubbing process creates huge amounts of a byproduct called calcium sulfite. This plant could create more than 3 million gallons of calcium sulfite slurry each day. First Energy created a process that turns that waste product into a valuable building material called gypsum, which is used to make wallboard or drywall. The slurry leaving the scrubbers is thickened and pumped through a forced oxidation gypsum or fog system. Oxygen is then added, changing it into gypsum, which is dried, treated, and sent to a gypsum manufacturer to make wallboard. First Energy recycles about 500,000 tons of gypsum each year, enough to manufacture wallboard for 70,000 new homes. Precipitators are another method of extracting coal ash, also called fly ash, which can be recycled or deposited in landfills. This mechanical process extracts fly ash left over from the combustion process. These poles, called wrappers, shake fly ash from a vibrating wire. Gas from the furnace, containing fly ash, flows into the box. The fly ash drops into a storage chamber and is blown into silos to be loaded into a truck. Fly ash from First Energy plants is used in manufacturing a variety of products, including concrete, grouting, roofing shingles, granules, and anti-skid road materials. First Energy also uses selective catalytic reduction technology, or SCR, to reduce nitrogen oxide emissions. SCR systems work much like a catalytic converter on a car. Flue gas containing nitrogen oxide emissions from the combustion process is mixed with ammonia. The mixed gases travel through a series of catalytic layers, which causes the nitrogen oxides to react with the ammonia. The reaction converts the nitrogen oxides to water vapor and pure nitrogen, a benign chemical that makes up 80% of the air we breathe. Both elements are returned to the environment through the station's stacks. Now that we've taken a look at how electricity is produced and some of the environmental control protection systems used at our plants, let's take a look at how the electricity is delivered to our homes and businesses. Transformers located just outside the plant boost the power from 18,000 volts to 345,000 volts, so it can travel long distances over transmission lines to where it is needed. Substations located along the path reduce the voltage so it can be moved along distribution lines attached to the utility poles. As the electricity nears customer locations, transformers on poles step down the power for use in homes and businesses. We hope you enjoyed seeing how electricity is produced at First Energy, where our energy is working for you.
So, in the next slide after the video is the operation, carbon dioxide emissions. As coal is mainly carbon, coal-fired power stations have a high carbon intensity. On average, coal power stations emit far more greenhouse gas per unit electricity generated compared with other energy sources. In 2018, coal burnt to generate electricity emitted over 10 GT CO of the 34 GT total from fuel combustion. The overall total greenhouse gas emissions for 2018 was 55 GT CO, or short for gas per unit electricity. Next is mitigation, phase out. The most cost-effective way to limit global warming to 1.5 degrees Celsius, a target of the Paris Agreement includes EU and OECD countries closing all coal-fired power stations by 2030, China by 2040, and the rest of the world by 2050. Next is conversion. Some power stations are being converted to burn gas, biomass, or waste, and conversion to thermal storage will be trialed in 2023. So next is carbon capture. As of 2019, retrofitting existing coal-fired power stations with carbon capture and storage is being trialed, for example in China. But this reduces the energy output and for some plants may not be technically or economically feasible. The economics of retrofit in China are still being researched. Environmental impacts. First is water use and pollution. Large quantities of water are often needed to remove impurities from coal. In the process is known as coal washing. For instance, in China, around 1/5 of the water used in coal industry is used for this process. This process helps reduce air pollution as it eliminates around 50% of the ash content in the coal. The other one is air pollution. The burning of coal releases many pollutants, oxides of nitrogen and sulfur. In particulate matter, they also emit greenhouse gases such as carbon dioxide and methane, which are known to contribute to global warming and climate change. To simply explain the environmental impact in water use, totoo na mas malaki yung nagagamit nila na water dahil ginagamit ang water para mas malinis yung coal at matanggal yung mga undesirable particles. And then, in air pollution naman, nakaka-apekto talaga ito sa air dahil nagpo-produce ito ng usok. Pero, ito yung way para matulungan sila na makapag-produce ng electricity. Kaya lang, naaapektuhan ang greenhouse gases and nagkakaroon ng climate change dahil sa process na ginagawa nilang ito. So, another reason why coal power plants are bad is because the air pollution coming from the coal-fired power plant is linked with asthma, cancer, heart and lung ailments, neurological problems, acid rain, and global warming, and also other severe environmental and public impacts. And this is my report about coal-fired power plant. Thank you and God bless everyone.